Welcome to Pave It Black.
Hi, everyone. This is Pave It Black, the official podcast of the National Asphalt Pavement Association. My name is Richard Willis.
And I'm Brett Williams.
Today, we're talking energy. And when we think about the 4 industry goals that we put out as a part of the Road Forward in January of 2022, a lot of it revolves around where we're getting our energy and how are we going to be producing and constructing our asphalt mixtures. When we think about transition from electricity to renewable energy providers in terms of our electrical production and needs at our asphalt plants, there are times we start to think about moving from diesel generated equipment to, can we electrify these vehicles or use some type of renewable source? There's a lot of unknowns in how we're going to move to a net zero future. And a lot of those questions do tie back to energy source and energy needs.
So with industry's goals and some of those goals being fairly dependent on companies that generate and distribute electrical power, I'm interested to learn a little bit about the efforts that are being made to generate cleaner electricity and what measures are being taken to address large shifts to electrification.
So to help us answer some of these questions today, we've invited Peter Balash from the Department of Energy. Welcome to the podcast, Peter. And can you tell us a little bit about yourself and what you do with the Department of Energy?
Certainly. Thank you. My name is Peter Balash. I am stationed at the National Energy Technology Laboratory in Pittsburgh, Pennsylvania, and we are part of the Office of Fossil Energy and Carbon Management in the U.S. Department of Energy. I am an economist, and I run a group of systems analysts, primarily engineers and physical scientists and some economists that look at energy process analysis as well as energy markets. And we provide analysis for the programs at the Department of Energy, and we are asked to keep track of macro trends in the industry as well as technology developments in specific parts of the energy producing industry.
So Peter, here at NAPA, and many of our NAPA members are pretty familiar with what FHWA or USDOT are working on or some of their focus areas. I'm curious if you could maybe share a little more about what the Department of Energy is working on or focused on these days, maybe a little bit about the mission of the department or what are top of mind big ticket items for the agency these days.
The Department of Energy was founded in the 70s, and it brought together a number of disparate programs in the government under one roof. What people may not know is that about half of the budget of the Department of Energy is to maintain the nuclear arsenal in the United States and also legacy management of radioactive sites caused by the nuclear weapons program. The other half of the Department of Energy is one that probably makes the headlines more, and that is the discretionary budget of the DOE. And it is separated into renewable energy, energy efficiency, nuclear energy, and fossil energy. The historic mission of the Department of Energy was energy security. It was born out of the oil crises of the 1970s. What people may not remember is that oil was used in about 25% electricity generation in the 70s. And so coal and nuclear power were favored to replace oil in the electricity generation sector. With respect to petroleum, alternative fuels were pushed in order to make up for apparent insecurity of oil supply. That changed in the last 15 years or so with the shale oil, but the mission of the department has been twofold. One is energy security, and the other one is environmental responsibility. So trying to make the two meet. How can we be energy secure at the same time? How can we meet the environmental objectives of the United States? So in recent times, the mission has pivoted more towards climate change mitigation, technology development to reduce emissions, but at the same time, reduce emissions while maintaining the industrial base of the United States. You asked me what we're working on. The Renewable Energy Office works on renewable energy technologies, better solar technologies, better wind technologies, better geothermal technologies. The energy efficiency part of that group looks at end use. How can things be either more efficient or use alternative feedstock? The Office of Fossil Energy in recent years has focused on more efficient power plants and higher rates of capture of CO2 from the flue gas streams of power plants. With the Biden administration, that's been expanded to industrial sectors. So are there opportunities for carbon capture in industrial processes such as cement, such as steel? And even beyond that, are there opportunities for sucking CO2 out of the air in something they call direct air capture? In general, wherever there's a source of heat rejection, there's an opportunity to capture the gas and separate the CO2.
I was sitting in my office a month or two ago, and I got a random text message from one of our members where they were cleaning out some things and they had found an award from 1990 where they had gotten a recognition from the DOE as being a company that was using innovative energy sources or energy management. Are there any programs out there right now through the Department of Energy where companies or industries can partner with you to look at using energy more efficiently or changing the way that we do business in an innovative way to help marry some of the industry and administration goals towards moving towards net zero?
Yes. In general, the department spends its money through funding opportunity announcements. So Congress appropriates a lot of cash for given programs. Some of them might be in the field that interests one of your members. And it will come out either of the Energy Efficiency and Renewable Energy Office if it has to do with advanced manufacturing. So the Advanced Manufacturing Office is in the EERE, the Energy Efficiency Renewable Energy part of DOE. It is in Washington. It has a large field office in Oak Ridge National Lab, but the AMO and the EERE put out the funding opportunity announcements. It's commonly known as solicitations. Before they do that, they put out a request for information or a notice of intent to award money. And they define the areas in which they're interested in technology development. The DOE ranks technologies by something called the Technology Readiness Level Scale. The lower you are on a scale, the more blue sky you are. So a TRL of 1 is something that's in a university professor's office on his desk. If you're up to 10, it's ready to be applied in industry. The lower TRL notions are more experimental. You get to bench scale around 3. You get to pilot scale in the mid TRL levels, and then you get commercial demonstrations in the 8, 9, 10 level. The applied labs, NETL, the lab I represent, is one. Another applied lab is the National Renewable Lab in Golden, Colorado. And the third is the Idaho National Lab, which is the Nuclear Energy Applied Lab. We tend to operate in the mid-levels. And that's important to know because the federal model of research and development with industry is that technologies that are at the lowest TRL levels are 80% funded by the federal government, and they require 20% cost share from the industrial partner. So if you had an industrial partner and wanted to work on a technology, they would have to supply 20% of the money either in kind through labor and facilities or in cash to the project. The government would fund the other 80%. As you get into the commercial demonstrations, the government will give you 50% cash and the industrial partner has to come up with the other 50%. So whatever area they're looking at, there's an area in DOE that's active, and I could give you some links to doing business with DOE to focus that answer.
So you mentioned some of the work that the agency's doing on renewables and more efficient generation, but I was curious if you could maybe share what efforts are really being made to achieve a clean grid, and then if there are hard dates set for achieving a clean grid for the U.S.
Well, the Department of Energy develops technologies that can be used by others to deliver clean energy. The Department of Energy per se does not control the grid. The Federal Energy Regulatory Commission, the FERC, is a regulatory body with authority over the interstate grid. When we say grid, we sometimes use the bulk power system to refer to transmission and generation. Generation producing electricity, transmission are the high voltage lines that carry it long distances. Distribution is the level of electricity below the substation. So you'll have a substation in your neighborhood or relatively close to a load, which is demand. And those are the wires that you see in your neighborhoods and in the cities and such, lower voltage. Some of the renewable energy operates at the distributed level, solar power on your house, whereas coal, nuclear, natural gas combined cycle, the big wind farms, they operate at the bulk power system level. They have to transmit those electrons across transmission grid and then step it down into the distribution grid. The distribution is controlled by states. The state level public utility commissions control investment in the distribution. Depending on the state, you have PUC control over generation, such so you'll have mandates for this or that level of clean energy, perhaps. In regions of the country that have a more deregulated electricity market, the generation is built at risk to the capital owners. So if you wanted to build a natural gas combined cycle or a solar farm, you can do so, and you put into the regional grid operator a request for interconnection to the grid. So that happens in PJM, Pennsylvania, Jersey, Maryland area, which is much larger than those three states, but that's the largest electricity market in the United States. The electricity grid in the United States is in three distinct areas. The Eastern Interconnect, which is from the East Coast to the Plains, the Western Interconnect, which is the Plains to the West Coast, and then most of Texas is its own. FERC has control over the West and the East. ERCOT in Texas is not FERC jurisdictional because it's solely within the state of Texas. But that's important because some of the best renewable sources, for instance, wind, are in Oklahoma or Iowa or somewhere in the plains. But that's not where most of the demand for electricity is. Those are in the cities. So you would have to transmit those electrons over large transmission wires to other parts of the country, and that gets into jurisdictional issues between the FERC and the states and who pays for those wires. So those who are electricity geeks, they know all this stuff, but you have to follow the FERC commission hearings, how they try to set up payment mechanisms for those lines, who gets compensated if their land gets taken for those lines, and so on. So energy infrastructure is very difficult to build because of varying interest and various impacts of building that infrastructure, whether it's electricity wires or natural gas pipelines or nowadays CO2 or hydrogen pipelines. So those are the constraints, the real constraints that are on the system. Various regions of the country are more ambitious than others in trying to advance renewable energy or less carbon intensive energy. The dates are aspirational, meaning those are goals. The actions of the government are to push, encourage, somehow incentivize states and regions to go in that direction. But it's an open question who has the authority to do that because of the federal system of the United States.
So we've talked a little bit about in terms of like electrical, what's being done there. But there are a lot of other energy sources that we use in this country, and whether that is fossil fuels for vehicles or for generators or other types of devices that are out there, what efforts are being made to kind of further develop cleaner energy sources or make it where they are maybe potentially more mainstream for those types of use? Because in our industry, we do use a significant amount of burner fuel to heat our asphalt plants. Or we use a significant amount of diesel fuel in our fleets and our equipment. Are there efforts being made to try to shift these types of technologies in a new and cleaner direction?
Yes, there are. It's helpful to step back and know the scale of the challenge. essentially, the United States consumes 100 quadrillion BTUs of energy a year. It's vacillated between 97 and 101 the last 5 years. It went down in the pandemic. In 2021, it was 97 quads of BTUs. 80% of that is fossil fuels. 8.5% is nuclear power. And renewables are about 12, 13%, of which electricity is about 2/3. And of that electricity, of 7 quads of renewables electricity, about 4 of that is wind and solar. So you have a 100 quad economy, you have 4 quads coming from wind and solar. In terms of your industry, you depend on petroleum, both for the crude oil to mix and also for the fuels to run your machines. There are efforts that in the EERE for alternative fuels. Sometimes that has been only ethanol. Sometimes it's biodiesel, making diesel out of animal renderings. I mean, there's all sorts of things you can make oil out of, but how much that can be scaled up remains to be seen. So some of the farther reaching R&D for oil would surround algae. I know that the department and also ExxonMobil have looked at large algae ponds that are fed CO2 from some CO2 source, and that grows the algae pond, and then you can process the algae into fuel. That would be a long-term R&D development for a cleaner fuel future. You'd still use the same machine, but it would run on diesel made from algae. But that could take many years before that's developed to a commercial scale. Some of your machines could be possibly use electricity, and the grid is changing. So in 2008, coal generation was 50% of electricity generation in the United States. Now it's in the low 20s. Most of that decline was attributed to the ascent of natural gas. So with the shale gas revolution, so to speak, natural gas became far more prominent in electricity generation. But still, fossil fuels are about 60% of electricity generation, the balance being nuclear and renewables. For renewables to grow, if you wanted to double, triple, quadruple renewable generation, it has to overcome its challenge of intermittency. So there's 2 general kinds of intermittency with renewable power. It's the daily, the sun goes down at night, the wind oscillates during the day. And then there's seasonal. It's the seasonal aspect that's perhaps the most problematic, in that this time of year, for instance, large high pressure systems sit over parts of the country, baking them. The wind speeds die. So they only produce at a small percentage of their rated capacity. So a wind farm can sometimes, let's say you have a 100 megawatt wind farm, sometimes it produces at 85% of that rated capacity, 85 megawatts. And other times it produces at 4%. So there's a wide range. Energy storage technologies are being developed to try to smooth that out. But energy storage is an inventory, it's a cost. And so it costs money to store energy and then use it when wind generating turbines are not operating at high rates. So the department is working on what it calls long duration energy storage in order to mitigate the intermittency problem that renewables face. Now it can be batteries, is the common technology, can be compressed. And now we have another effort in hydrogen as an energy storage medium. And there's quite a lot of work going on in real time in the department. There are in the use of hydrogen to replace fossil fuels or to back up renewable generation so that the grid can more reliably produce clean energy for use in electrification scenarios. So how much of your process in making asphalt can be electrified? I don't know. You can tell me, but that would depend on the source of electricity also being cleaner. If you could be assured that the grid is getting cleaner, then if you use electricity, then you would have a less carbon intensive process.
So I was looking at the National Energy Technology Laboratory website, and I saw some mentions of the carbon capture initiatives. And then you also mentioned a little bit about some of the work with carbon capture. And I was just kind of curious, um, maybe to learn a little more about where that technology stands, maybe in terms of like the readiness scale. I know you mentioned being able to possibly capture heat sources from the exhaust gases and those type of technologies. I just didn't know where that technology stands as far as readiness or ability to deploy, and then maybe some thoughts on where you see that going in the future.
Well, I think the state-of-the-art carbon capture is ready to deploy. Advanced carbon capture is still an R&D endeavor. There are commercial solvents, amine protein solvents that can absorb the CO2. And forgive me, I'm an economist, not a scientist, so I might garble the words here a bit. But we've demonstrated that at the Petronova plant in Texas in the last decade, which was a technical success. It's been demonstrated in Canada at Boundary Dam Power Plant. It is technically feasible to deploy carbon capture and storage, but it's complicated because of many reasons. I'll go over a couple. One is the market. Right now, there is no incentive outside of a tax credit to deploy carbon capture and storage. And while that tax credit might be large, there's no penalty for emitting CO2. So you can build say a natural gas combined cycle plant with carbon capture and obtain a credit, but the competition can build a natural gas combined cycle plant without carbon capture and make more money because it produces electricity at lower cost than the plant with carbon capture. So they would win in the merit order dispatch of the electricity sector. To overcome that is a policy question. But on an R&D level, what the department's working on is higher rates of capture. So traditionally, that is the first 20 years of this century, the department worked on trying to get to 90% capture of a flue gas stream from a power plant, the flue gas stream from a cement kiln or something like that. If it were steel, carbon capture would be from coke oven gas, taking the gas stream and separating out the CO2 from it. Traditionally, we were aiming at 90%. Now we're aiming at 96, 7, 8%, trying to push technology to its limits. It doesn't get you net zero, but gets you very close to net zero. And the department has also taken an interest in direct air capture, which is far more expensive than point source capture, but it allows the possibility of separating out CO2 from the air. The primary sources of CO2 are from power plants, and the cost per ton of CO2 separation is a function of how much of the gas stream CO2 represents. So in a coal plant and in a refinery plant, that might be in the 12, 13% range. For a natural gas combined cycle plant, it's 4 to 5%. For direct air capture, it's in parts per million. So you're going to have a lower cost in the more CO2 rich streams. The easiest place to deploy CO2 capture is industrial processes that have pure CO2 streams anyway. And those are things like ethanol plants, but they're a small portion of the industrial economy in the United States.
That's really interesting. And I think that helps clarify a lot of the confusion and kind of unknowns and mysteries around those concepts. Going from something that is that kind of an unknown to another unknown we have as an industry is we did set forward a goal trying to align ourselves with the current administration goals that as an industry, we want to move forward to try to get to net zero emissions as well. But again, as I alluded to earlier in the conversation, a lot of our processes involve a fair amount of heavy equipment that are often kind of diesel powered. And one of the things that we often hear from people as we're talking about these types of movements are, how are we going to move towards equipment that can run on clean energy sources? And right now, the current push seems to be moving towards electrifying most of vehicles, and whether that's fleets or passenger cars. But at the same time, we're hearing about the pushing towards electric vehicles. You're also hearing about states and areas of the country that are having rolling brownouts because during the summer they can't handle the electrical demands that are being put on some of the different systems in our country. And so how do these companies move forward with the realization that, yeah, the country's in the process of changing our supply and preparing ourselves for a future where there may be more electrical demand, and we're going to have a system that's set up to do it? Because the last thing that a contractor is going to want to think about is, all right, I'm now have an all electric fleet, but my power company is going to give me an email that says we're doing a brownout for part of the afternoon and I'm not going to be able to charge my equipment, which means then I can't work at night. And it may seem kind of silly in terms of an example, but those are some of the things that people wonder about, at least from our industry, on what's being done and how can we have confidence to invest in this type of equipment. Even the manufacturers move forward thinking that, yes, there will be a system that's set up one day to handle these demands if we innovate and start developing this type of equipment.
Well, I guess as an economist, I would advise a portfolio approach rather than all eggs in one basket. And I don't know how easy that is for any given member of your association. But the easiest thing in some ways is to have more efficient diesel engines. And that would use less fuel per mile driven. If the diesel engines get better, then you'll reduce emissions for the same level of activity that you have. A variation on the diesel theme, Cummins, for instance, has worked a long time with EERE on alternative fuels for a diesel engine. So biodiesel. So to the diesel engine makers, diesel is diesel. So if the natural feedstock can be used to make diesel up to the specifications of the fuel needs of the engine, then that's great. The only question there is scale and whether there's enough biodiesel that could be made to replace petroleum diesel for industry. With electrification, you're right. You don't want to be caught in the situation having an all-electric fleet and then the power's out. And if you're big enough outfit, maybe you have a diesel generator backup to your plant. So that would be a more expensive way of powering your fleet than what you had before. So it's a bit of a chicken and egg thing. The association does not control the electrification of the grid. That has many players behind it. It's in the public interest to have reliable energy. There will be bumps on the road as the state mandates for higher proportions of clean energy, along with the federal subsidies for wind and solar investment. There will be more wind and solar on the grid. How that gets managed so that the grid is reliable is a task of the Office of Electricity within the DOE and the FERC and the local electricity authorities. As that goes on, you will see pressure for better energy storage technologies. The price of electricity is likely to go up because you're building more capacity, you're investing more capital in order to provide the same level of kilowatt hours. As a result, the price will have to go up, maybe not at the bulk level, but at the delivered level because of the increase in the amount of investment in generating capacity and in transmission capacity and in energy storage technologies. So none of it will be especially cheap, but as the goal is to reduce emissions, eventually I would see a market construct being in place that would try to make the transition more efficient than what's happening at the present time.
So in terms of the electrical capacity of the country, is there generally some spare capacity in the system? And then I'm kind of curious, I mean, you mentioned some of the organizations that are involved in expansion or how that's managed, but I'm kind of curious, like, is it purely market driven in terms of expanding the system? Or I guess, what are the drivers that kind of push the increased generation or capacity for technologies coming online?
The organization that tracks this is called the North American Electric Reliability Corporation, known as NERC, NERC. Every year they put out something called the Long-Term Reliability Assessment, which is a 10-year outlook for North America. And it's North America because the Canadian grids are interconnected at certain points with the US grid and also a small part of Mexico. The spare capacity differs by region of the country. So there's very little in California. There's very little in Texas. There's a lot in PJM because PJM stretches from Baltimore to Chicago. So that's the industrial heartland of the United States. There's a lot of electricity generating capacity that's old, and that is being retired. So the coal fleet is being retired in that area. It's also being retired in the mid-continent area. The organization there is called MISO, M-I-S-O. They're the ones that have been issuing worries about potential rolling blackouts because lack of spare capacity under high demand scenarios that occur during hot weather. We've seen episodes of high demand in the winter, which is the added complication of natural gas being used for home heating and space heating. It puts further strains on the grid. So the organizations that are responsible for reserve margin are the regional transmission organizations or the independent system operators in areas that have been restructured. So that's about 2/3 of the country. But the rest of the country is in cost of service. Traditional regulation is responsibility of the state public utility commission and the incumbent utilities. That's most of the West and the south of Virginia. So there isn't any one group that's responsible, but to the group that brings it all together for reliability purposes, that issues standards, that issues warnings if reserve margins, that is the level of spare capacity, is going to be too low, is the NERC. So I would encourage you to look them up. Again, that's the long-term reliability assessment that comes out every fall.
I was curious if there are any other areas in the electric sector or efforts that the Department of Energy is undertaking that maybe industry really needs to stay on top of, that we haven't put up, or things that we should be paying attention to. Just wanted to see if you had other ideas of things.
Yes, I would watch the funding opportunity announcements that come out of the Infrastructure and Jobs Act that was passed last year. There is quite a lot of money in the grid area. There's a new office in DOE called the Grid Deployment Office. And the head of that office is a lady named Pat Hoffman, who's a well-experienced and highly talented administrator in the government. But they will be putting out announcements on modernizing the grid, the power electronics that are necessary to modulate flows. When you have distributed energy such as solar, you have possibility of energy going two ways on the grid. Instead of just going from the power station to your house, you could go from your house to the grid as well. If electric vehicles actually became a big portion of the motor fleet, then possibly those batteries could be discharged into the grid at, again, the distribution level. So there is a lot of electrical engineering issues surrounding how that would work and still have a stable grid. So I would look there, and then I would also look at the energy storage funding opportunity announcements that would come out of EERE. But there is a new office in the Department of Energy called the Office of Clean Energy Demonstrations, which was part of the Infrastructure Act. They are standing up, and they will be overseeing quite a bit of the funding opportunity announcements that are emanating from the $62 billion that were put into the Department of Energy's budget by that act. So if you have policy wonks in your association, I'd have them read the Infrastructure Act. And if you want, you can get back to me. I can put you in contact with people who are more knowledgeable about any specific paragraph in that long tome known as the Infrastructure Act.
We definitely have some people that we can ask to read parts of that for us on that. And so thank you for that. And Peter, I just want to say we really appreciate the time you've given us today. And I know I've learned a lot. This isn't something that I or a lot of our members are very familiar with. We're very familiar with Department of Transportation and even like the Environmental Protection Agency, but DOE is not a group that we commonly deal with. But I think especially as we start to look towards using cleaner energy and looking at the way we run our businesses in terms of economics, but also emissions, understanding how that department works and what they're working on will be more and more critical for our industry moving forward. So thank you for being here with us today.
You're welcome. And I was delighted to take part. And thanks for thinking of me.
My big takeaway from today really was how, as an industry, there's definitely opportunities out there to start looking at cleaner energies or cleaner fuels that we can use in our operations. But I think it's going to be a stepwise program. We're not going to make a wholesale change. We got to really investigate the opportunities and really understand how those could impact our operations. But you can tell that all the way from the federal government to state government to local companies that are in the electricity sector are working on cleaning the grid, cleaning the generation of power. But there's a lot of levels there and a lot of effort that's going into that. So it will take time. That was my takeaway from today's conversation. How about you, Richard? What'd you take away?
That I'm ignorant in how energy is supplied in this country. No, I think one of my big takeaways was it's a complex process and there's a lot of moving parts that we don't necessarily think about. We typically complain about the general public doesn't think about roads until there's a problem. And a lot of times I don't think about energy until I flip a switch and something doesn't happen like I want it to. I think understanding these processes and understanding what groups are working on it allows us as an industry to even understand where to go with questions and realizing there are a lot of people working on this and it's not something that's going to be solved overnight. And I think it's okay to have questions about where we're going in the future, but I also don't think that we need to let those questions be barriers towards moving forward. It's realizing that this is the direction that it's a common push. It's a potential new and kind of brave future that looks a little different. But one of the things that he talked about very early on in the discussion was really when you get down to it, the department was founded with something in its mission, and it's still that today, and that's energy security. And that wherever these pushes are going and wherever these directions that we're trying to take it, ultimately the Department of Energy is trying to make sure that we have the energy that we need as a country to do our businesses or run our lives. And there's a group of people that's like, my job is to wake up and think about asphalt and making sure that it's done well. Their job is to wake up and think about how do we get the people in this country and Americans the energy that they need to run their lives. And that should give us a little bit of comfort, especially as we are moving in a direction that we don't necessarily know where it's going.
Thanks for listening to Pave It Black. Visit asphaltpavement.org/podcast to find more episodes, suggest a topic or guest, become a sponsor, or learn more about Napa. Pave It Black is produced and copyrighted by the National Asphalt Pavement Association. Music by Colleague. As always, thanks to the dedicated workforce connecting diverse communities all across America. Keep on paving it black.